Hey there, guys and gals. We are going to be talking about proving lines parallel. So, we talked about some theorems and postulates and things for if lines are parallel, what's true about them. We talked about some vocabulary things, same sides and alternates and all of those things. In this lesson, we're going to take a look at excuse me, we are going to drill down and basically using the converses of several of those postulates and theorems in order to prove that two lines are in fact parallel. So let's kind of jump in and so we're going to use kind of this picture right here for a lot of these examples. We're going to hit several theorems, and then we're going to do an example using them, and then we're going to be good to go there. Okay, so the first theorem, or it's actually a postulate that we're going to look at, is the converse. Now remember, what does converse mean? Converse means that we flip that theorem around and we flip that hypothesis and conclusion. And these are all of these new ones pretty much are going to be the converses of them, basically saying, like in this one, if two lines are cut by a transversal, so the corresponding angles, so we're talking about like this, let's see, let me put a thing where I need it. There we go. We're talking about, like, say this one and this one, right? So those are two corresponding angles. We could have these two, or, etc. We've hit that in other lessons, right? So like those two there. If those two are congruent, then the lines are parallel. So again, we're saying the opposite, the converse, the flipped around version of that corresponding angle postulate, where if these two lines are parallel, then these two are congruent. Well, in this case, we're saying if they're congruent, then the two lines are in fact parallel. Okay, so that's the first one, right? Easy peasy. Then the next one, this one's a little bit different. This one's not a converse. This one is a little bit different here. This one this postulate allows us to say all of the rest of the theorems, this particular one. And it says that if we have a point, so like say there was a point, let me do it in this yellow color. If we have, so say this line and then a point over here, right? If we have this line, then it says that there is one and only one line that is on the same plane and that goes through here and is parallel to there. So since there's only one line that goes through that point that is parallel, that means that that lets us say specific things in these next couple of theorems. So let's take a look at these next couple of theorems. Let's jump in. Okay, so bop, 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 bop. Try again. Okay, there we go. Say, the converse of the alternate exterior and interior angle theorems is the same idea, except we're talking about theorems this time. So these could be proven. You could be assigned a problem where you had to prove one of these, right? So the alternate exterior angles would be ones like this one and that one, or this one and that one, right? And then the alternate interior, of course, would be the ones like this and ones like that. Those two are alternate interior ones, then alternate exterior. If they are congruent, then the lines are parallel, right? That's where you should be noticing a trend going back several lessons. We're just flipping a bunch of these around. So let's hit the next one. Let me erase some of this chicken scratching on there. Oops. Yeah, that's fine. Totally fine. Totally fine. So the same thing applies when we're talking about consecutive, or I like to use that same side name because it's just easier to remember. We remember same side supplementary, right? So we get to remember same side supplementary. And so if we have a pair of same side angles, so either exterior or interior, right? So like these, for example, would be some. If those are supplementary, then the lines are parallel. Easy peasy, lemon squeezy. We only have one more, and then we're going to do a quick example. This ought to be a fairly quick video because it's just kind of reinforcing the same theorems and postulates we've been looking at before. We may include soon a video specifically of a proof using these, but for now, we're just going to you'll see the example at the end. It's going to be pretty straightforward. All right, so we got one more. And label it right, but we're going to actually make this go away because this one takes up a different picture. So for perpendicular transversals, if a plane, what? Oh, in a plane. If a plane, if, no. I can read and I can remember what I'm trying to say. In a plane, if two lines are perpendicular to the same line, then they are parallel, right? And this is really this is really, like I said when we first introduced the converse of this converse, double negative there, this is kind of a continuation of the corresponding angles theorem or postulate as well. It's just making more specific. We'll see this repeatedly throughout this course. We get some theorems and postulates, and then we get some for right angles specifically that where we have to know even less information, right? Because it gives us a bunch of extra stuff because the lines are right angles. All right, let's do one example in this video. This is going to be similar to examples we've seen before, right? So we've got this picture here, and we want to find the measure of angle HEB. So that is right here, right? So we're talking about this angle right there, its measure, such that lines L and P, so these two lines are parallel, right? So that would mean that these two, what are these? Well, let's take a look at them. These two are, all the C words flashed through my head and they were all wrong. These two are corresponding, right? Corresponding angles are congruent, right? So if these two are congruent, I'm pointing down here, you can't see what I'm pointing to. If these two are congruent, then that will make these parallel. So since these two have to be congruent, what do we do to solve this thing? Well, it's really, really straightforward. All we have to do is we have to set these two expressions equal. So we're going to say 8x minus 11 equals 5x plus 2. Now we're going to take and solve for x, which is going to be super duper simple. We are going to, how about add 11 to both sides? There are other ways to start this one, of course. Y'all probably practice enough with equations that you may have solved this a different way, and that's great as long as you take legal steps that get you to the right answer at the end. So 8x equals, then we bring down our 5x. Make sure you bring down all the things that we don't touch, including signs. If there's negatives and things, make sure you're bringing down everything. Every time. It takes less than a second. And a minute fraction of a cent of graphite from your pencil. So don't skimp out on bringing everything down because you'll make mistakes that way. So 2 plus 11 is 13. I just kind of randomly put these numbers in here. We're probably going to end up with some ugly answer in the end, but that's okay. We'll live. Right, so we need to get this guy over with his friend. So we're going to move the 5x over. In order to move it over, we subtract 5x from both sides. Minus 5x, minus 5x. Okay, this one's cancels. So we've got 3x equals 13. How is that 3 attached to the x? It's multiplied. How do we get rid of it? We divide. Right, divide by 3, divide by 3. That cancels. So x equals 13 thirds. Now, we're supposed to find the measure of the angle, so we got to do is we got to take and substitute this mess in over here. You can actually do it in either one since they're congruent, right? But we'll just plug it into this one. Now, I may pull up a calculator in a minute because I made ugly numbers because I didn't really take the time to think through it, which is okay. Sometimes we get ugly. The higher up in math, I don't know why I wrote an 8. How about 13 thirds plus 2, right? And so that's what we're looking for, the measure of angle HEB equals this. Let me pause our video and let me pull up a calculator. All right, got my calculator out. So we're going to do 5 times. Actually, I don't think that works on this calculator. I think I have to put the times thing in here. I think. No. 13 over 3. close parentheses, plus 2, right? Now, there's other way you could use a fraction button. I don't even remember if this calculator has a fraction button, but you know, this is a straightforward way to put this in this particular calculator. You can put it in your calculator, however that works for you. I'm going to push enter, and we get 23.67. So the measure of angle HEB equals, what did I say, 23, right? 23.67 degrees. Don't forget that degrees symbol. Numbers that have units should include the units. And that's going to be it for this video. I think we've got one more in this unit. We'll see you there and see you later. Bye-bye.